pain and pleasure are like core features of consciousness, can they actually, and they seem important for humans operating in the world, can you actually construct that in a machine?
Hi, everyone. Welcome to the first ever podcast recording of Curiosity Podcast, where we go deep with an expert in their field. The tagline is delivering 10,000 hours of learning in 1 hour. So that's an ambitious tagline. I'm Imad. I'm the co-founder and CEO of Mercury. I've been doing kind of startups and investing in startups since 2006.
I'm Raj Suri. I'm the founder and CEO of Presto Automation, which delivers AI type applications for traditional industries like restaurants. Also co-founded Lyft. And yeah, very excited to be co-hosting this with you, Imad. This is an opportunity to go really deep into some really interesting areas with some of the smartest people and most thoughtful people on the planet. So excited to be able to explore it, in depth.
And today we have Amjad Masad with us. He's the co-founder, CEO, and I believe now head of engineering at Replit. What's the one line of Replit, Amjad?
It's the fastest way to make software. We have a platform that provides an online programming environment that's collaborative, and we have a large community of developers making things for each other, for other people. And we're getting into supporting teams of developers in the same way that, say, Figma is a collaborative design program. Replit is kind of that for programming.
What's kind of interesting is it started relatively small, right? This was like an IDE online, and I think you were like compiling whatever programming to JavaScript and running it on the browser, right? But now it's this kind of hosted package combined with the teams, combined with like learning and template. Like, do you think, was that always your vision that you're going to like progressively get to this level of like product, or was it kind of incremental?
I actually sort of saw a lot of it in my mind's eye pretty early on. And a lot of it is like pretty obvious stuff. I'm actually surprised that no one had built it. And because I started working on it in college in 2009, something like that. And then when I came to the US, based on an open source project that's related, I worked at Codecademy as a founding engineer and used this sort of the same technology that I built to like make browser coding possible. And then left that and went to work at Facebook, worked on React and React Native, was founding engineer on React Native. React Native is like the best way to make cross-platform mobile apps. And in 2016, revisited the idea and had found that basically nobody had built it, which was really surprising. It's sort of like it is the opposite of efficient market hypothesis. Like, why isn't the market not producing this? And I actually did not want to start a startup, but I was so compelled by this thing, and I knew that this idea had to exist. Well, it turns out I think the answer that why nobody had built it is because it's incredibly hard. But yeah, in terms of execution, it started very simple. But in terms of vision, it was always, I was an early GitHub user, like perhaps in their beta. I think I was so excited by GitHub. I was also so disappointed by how little they evolved beyond the initial sort of kernel of an idea. So I always thought about just like making a collaborative developer community that's like more exciting, that you can do more things in it, and yeah, I've always imagined a lot of the features that we're building. Of course, with time, just what became available in terms of technology, we started adding a lot of these things that I didn't really think about at the start. But overall, like even like now we have this tipping mechanism where you can tip developers. That was like I've thought about that like fairly early on. So it was actually kind of frustrating because, like, as you know, as a founder developer, you're sort of like everything feels like it's like one weekend of hacking away, and it's like turns out no, it's actually more than a decade of hacking.
Amjad, it's a really interesting description. You talked about the fastest way to make software, right? Is the primary user base people who don't normally make software or are not really comfortable setting up their own environment? Because that takes time. Or is it more of the power users who are, probably already, they already have a CS degree or something like that, or they have a lot of knowledge. What's the primary user base for this type of application?
One of the exciting things about running Replit is the user base is so diverse. It also makes it really hard to run the company because people like crave these simple personas. I'm sure you guys at your companies, like the design team or the product team, want to talk about one or two personas. But I always push back on sort of persona building because ultimately I tell them that we have one persona, and that persona is the developer, the software creator. Because like you start segmenting people into students or professionals or hobbyists, and all these segmentations are true to some extent. Ultimately, like if you're familiar with Clay Christensen's Jobs to be Done, I think that inverts the question. It's not like a customer segmentation thing, which is totally arbitrary, kind of based on user characteristics. It might be actually interesting to go into Jobs to be Done a little bit, but basically the idea is that most companies, the way they think about bringing a product to market is they think about a customer persona. That really confuses people about what they should be building and what the actual need that they're doing it for. And so Clay Christensen sort of switched that question of like his primary insight is that people hire products in the same way that you hire people. So when you go and you want some accounting done, you don't go look for a 30-year-old or like a middle-aged man in New York. You don't do that, right? You go and you say, I want some accounting done, and you find someone who's competent at accounting. In the same way that you want to get software done or you want to make software, you go to a place that makes it really easy to make software. And from that lens, I just think about our community as a sort of really the main jobs to be done here is that you want to make something. And it turns out students want to make something. They want to learn to make something. Hobbyists want to make something. They want to crunch some data. They want to make a fun app. They want to make a game. Professional developers want to make software to bring it to their customers. And so that's the sort of shared goal of our community. In terms of like the makeup of our community, it skews younger. And there's partly cultural, partly some product limitations. The cultural aspect is that developers tend to be very conservative people. They don't want to change their tools. And they're actually quite haughty and quite sort of, I love them. My best friends are developers. I'm a developer, but we're actually like difficult people. You see it in Stack Overflow comments. It can be a little, people kind of look down on things, and people kind of tend to not change too much with time. They stick to one language or one technology. And so
I was just thinking why someone didn't like make this innovation between like when you started in 2016. And I think it's partly because of this, right? Like developers are like, they often build like little incremental tools for themselves to make their life a little easier, but they don't think about like transforming their trade. Like you don't go like, oh, I want to like do it in this new way completely.
I think that's absolutely right, which is surprising because developers are the agent of change for the larger economy. or maybe it's not developers that are the agent of change. It's crazy founders that recruit developers to make changes. But it's a tough market because the habits really change really slow, and like there's common saying that programming changes one generation at a time, and that is sort of true. But today Replit has some product limitations that we're working through, mostly on the technology side, like just making an immediately accessible, instantly reproducible cloud development environments turns out it's like a very tough like distributed systems problem. Like one problem that we've like dealt with that sort of introduced like a big product limitation is that if you're introducing this multiplayer programming environment, there's a potential for what we call race conditions, which is like people like trying to edit the project at the same time, and introduces data corruption and all of that. So we use the file system, basically the system that manages your files, that was what we call atomic. So basically every time you do a write, you create a snapshot of the entire system. And that is really good for distributed systems to protect against data races and all of that. It also turns out it just introduced like a really hard limitations on scale. Like we can't have like a 1 terabyte disk per project. So you sort of some of the trade-offs we made early on turn out to be like created like limitations to how much power the platform has. But all of these are solvable. It just requires a ton of innovations, and so we're working through those right now.
I mean, that's really interesting. So you talk about, again, the fastest way you could possibly to build software is on Replit. What do you envision it will be the fastest? Give some examples of like, how fast someone could build something, how much faster they could build something in the future versus now. It'd be really interesting to, and I know, you're thinking about AI or probably already working on it, in terms of how it can support coding. It'd be really interesting to hear, you as the expert, kind of what the future looks like in terms of how fast someone can build something.
The fastest story I've heard on Replit is someone coming into Replit with an idea for a product and getting it 30 minutes later. And the way they got it is without writing a single line of code, is by relying on a human machine centaur of sorts. Basically, we have this bounties program where you can like you can pay some money and post like a description of what you want to build. Someone posted like a Figma. I actually tweeted about it. I was like, hey, I want to build this. And literally someone got them a prototype in like 30 minutes. And that person who's getting them a prototype is not just a person. They're also powered by AI because we have a ghostwriter product similar to GitHub Copilot. It's actually a little more advanced than GitHub Copilot because not only has the autocomplete thing, you can also chat. You can talk with AI that's writing code with you. And so it's like feels more like a chat GPT that understands your code and that sits right there with your editor. And so we're really trying to be unideological about how people make software. And the idea is like really trying to reduce the distance between an idea and a piece of product. Like, that's been the trajectory of sort of a human history where, if you're sort of hunter-gatherer and you have an idea for a product, it's sort of impossible to do it, right? Like let's say you want to build a spear. That in itself is like really, really hard. You have an idea for a hammer, for example. It's like impossible to find the rock the right size and do all that these things. Go into agrarian societies, and it's still pretty difficult to make things probably a little easier. Industrial society got way easier. You now had factories. You now had accessible labor. Capitalism becomes a thing where you can organize people in groups to create things, but it's still fairly difficult to get a product on the market. I think the information age is a reduction of this idea of like having an idea in your head and getting a product in the hands of people. And I think we can get it down to like on the order of minutes. like to get something on the market.
Like right now, you said like there was a human that was like potentially using an AI to like generate this thing, this kind of prototype. Is the eventual state that there isn't a human involved and like the AI is just generating something good enough, or do you think there'll always be a human in the loop with like our current AI at least?
So the way I think about automation is that it sort of like takes each of the jobs from the bottom up. That's like not always true, but for the most part true. I believe it's going to be true for software, meaning the low skill software creation, I think will get fully automated. So I think pretty soon, probably this year, there's going to be products, and maybe Replit builds that, but where you can go put in a paragraph description of a piece of software and get an initial thing with the code and with the app running, right? I think this will happen like very, very soon. But I think the AI is going to struggle to iterate on it. And I think you still need a person to kind of make it into a product that you can sell or you can maintain or you can scale. But I think the initial prototype or the MVP will be done by AIs like pretty soon, like on the order of months, perhaps a year or so.
Yeah, it seems like it'd be useful for like prototyping. Like you come up with an idea, like, what does that look like? How does it work? Can you get internal buy-in for that or even customer buy-in for that, for an idea? But to actually build complex software that works, that shows up to work, 99.99% of the time, it seems like we're still far away from that. Would you agree? Like that part will still take a lot of human effort to get there.
Yeah, I mean, this gets into the reliability of large language models. So maybe we introduce large language models for the audience, but basically, like, it's the latest technique in AI where it started in 2018 at Google with this technology called the transformer. The transformer is a type of machine learning model that has something called, the innovation that it has is the attention layer. So a neural network simulating attention in the same way that humans have attention. So now the machine learning model could actually sort of pay attention to parts of the input data stream. So for example, if you have a piece of text or paragraph, the machine learning model could actually sort of better understand it because of this attention layer. Turns out another innovation, just primarily from OpenAI, that you take these transformer models, you throw terabytes of data on them, and they start having these emergent phenomena. And by the way, nobody understands why, but there's what's called phase transition. Once you cross a certain number of parameters, like 1 billion, 2 billion parameters, meaning like how much, it's almost like neurons in the brain, how many neurons are in the neural network. They start having exponential rise in reasoning ability. So you throw a benchmark at them doing math, doing reasoning, doing translation, doing whatever, and they start doing better jobs. And literally the graph goes from horizontal like that, barely like increasing, to vertical.
I've never heard this like explanation of transformers in terms of attention. Can you explain that a little bit more? Like, what is it about the model that's giving attention, and like just like go one layer deeper on that?
Yeah. So previously, when we did language modeling, it was like, very explicit sort of task. We would do classical natural language processing. We would like construct a grammar, and we would do all these kind of things. Turns out the machine learning model can find the structure of language by interpolating different parts of the text, and by literally directing the attention to different parts of the text and relating it to other parts. So it can create it can like understand the emergence of structure in language or any sequence. And we can get to that maybe in a second, but let's focus on language. Because like, think about how humans like pay attention to things. Like attention is about cutting, right? It's more than just about like pointing to something. It's about cutting the noise. So when I'm paying attention to the screen right now, I am like deciding not to look at a bunch of other things. Machine learning models pre-attention. And I think a lot of researchers are going to cringe really hard about like how I'm describing this, but just for the layman, basically, it's now machine learning models are now able to discriminate within the inputs and the training data and try to understand, like pay attention to like the fox jumped over the the fox jumped over the
quick
gate.
brown fox jumped over
you can just like look at the fox and then look at other parts of the text and start understanding the emergent structure.
So with the transformer, when an LLM is like trained, you don't tell it like these are all the nouns in the English language, these are all the verbs, things like that. You just give it a ton of text and it like reasons about like the usage and like comes to its own kind of understanding.
Yes. So like that's the primary innovation here. Like machine learning essentially is about discovering algorithms. So Andrew Karpathy, head of CEO at Tesla, recently went back to OpenAI. He called it software 2.0. And the reason he called it software 2.0 is basically you go from programmers writing algorithms to a learned algorithms, meaning the machine learning, you give it an objective and it learns the algorithms. It's highly inefficient, but it's also a lot better than an army of humans trying to reason their way through programming.
So it seems like a similar kind of innovation to like AlphaGo, right? Where like instead of trying to teach it how like other players have played Go and things like that, you just kind of have the machine kind of play Go against itself over and over, and it can like reason like strategies from that.
Yeah, AlphaGo is super interesting. The generalization of AlphaGo, making it learn from self-play. Like you don't even have to give it the rules of the system. And so the advancement in machine learning is removing explicit design and explicit programming from these systems. And instead having the machine learning model discover them, because if it discovers them, it will be much better than us humans programming it. And Transformer takes it to the next level where now we're able to discover algorithms that understand the structure of language. And by the way, we keep saying language, but the interesting thing about Transformer is that they're not language specific. So anything that you can model as a language, Transformers would do really well at. So for example, Tesla uses Transformers for understanding traffic patterns. So they model the traffic like a language.
Wow.
And then the transformer starts to understand the structure of traffic better than explicit programming because it modeled it as a language.
Is that a transformer LLM that was trained on like kind of Reddit and then you're applying it to self-driving data? Or is it like trained on just like the self-driving data that Tesla has?
That's actually quite an interesting point because so GPT stands for Generative Pre-trained Transformer. The pre-trained part is an interesting part of transformers. That's why these models are called foundational models, because pre-training them, meaning throwing large amounts of data on them, is actually pretty good for them. It's inefficient, but it's pretty good. So like one discovery that OpenAI made is that if you train large language models on partially in code, they get better at just normal tasks and just language. And so the more data, the more diverse data you give them, generally they get better. There's a lot of tuning and fiddling that needs to happen, but generally they get better at these things. So whether Tesla used a pre-trained model that was trained on Reddit or whatever, I don't know. But generally how people use these models is they take something that was pre-trained by someone else, an open source, or Hugging Face has a bunch of pre-trained models, and then they fine-tune it on an application-specific thing. Because the model has some world understanding based on some pre-training data, and then you are sort of driving it to understand your application or your domain-specific thing.
You said OpenAI discovered that like if you keep adding parameters, it goes kind of like exponential, like the kind of how good the algorithm is. Is the like have they proved that it's an S curve? Like does it kind of go exponential and then flattens out, or is it like so far the more you throw at it, the more exponential, like the better it gets?
From the outside, like no one knows whether we ran out of scale, scaling returns on scale, whether we hit diminishing returns. Intuitively, everything has diminishing returns. Like if things don't hit diminishing returns, you get into a weird, because exponentials becomes just insane.
Is that true though? Like as in, I feel like, if you look at the graphs of like the GDP of the world, it seems to be on like a 300-year like exponential. So yeah, maybe there are some things that don't.
If you zoom in on the GDP, is it actually flattening, or is it? It feels like it's flattening.
It depends what time period you take.
No, I don't think it's flattening because you still have all these developing countries becoming developed, and there's a ton of growth there.
Yeah.
Just over the last 30 years, the growth of China would have been a huge increase in GDP, and then you have India coming up. So, anyways, that's a separate topic. But like, that's an interesting example. I agree that at some point you will see diminishing returns, even in the GDP growth. That makes sense.
Over what time period? Like we might be in a 1,000-year run of AI.
Yeah. Also, it's S curves. Like, maybe industrialism is diminishing return, but AI-ism is like another S curve, right? So, but broadly speaking, like generally in technologies, there's some S curve, and there are signs that we're starting to see diminishing return, and that those are indirect signs. And this is my opinion. The recent innovations in large language models have not been in scaling. They have been algorithmic innovations. The two primary innovations is supervised fine-tuning and reinforcement learning from human feedback. These are two algorithmic innovations that made ChatGPT what it is. So it wasn't pure scale that got ChatGPT to be this powerful thing. It was an algorithmic innovation. So the question is, if they thought that scale was still the best way to improve these models, then they would not have invested in these algorithms.
We'd love to learn more about those innovations. So you're saying that it's not just more training data that they threw at this model. They actually did a better job of training it, with the existing data that it had. You said through supervised learning and through human fine-tuning. Is that right?
Reinforcement learning from fine-tuning. So supervised fine-tuning is the cool thing about large language models, GPT in particular, is that it is trained in a self-supervised fashion, meaning that we don't have to label the data. Yeah, you can take Reddit and you can just like throw it at a language model and it understands the structure of English. Pretty crappy English, but it does understand. And turns out if you want the model to perform better, especially on a downstream application like say chat, then you go and you get a lot of data and you label it. And the way you label it is you just say, the most simple case of labeling is, hot dog, not hot dog, right? Like from the, I think, movie, from the show Silicon Valley. If you want to build a machine learning model that detects hot dog, you just take a bunch of pictures of hot dogs and a bunch of pictures of not hot dogs. You label those hot dogs, you label those not hot dogs. This is supervised learning. So it turns out if you give it supervised learning, it starts to perform better. Now, it still has a problem of like not really listening to people. This is the reliability issue of large language models, which is, I think I was trying to get to answer 6 questions ago or something like that, where I think the question was something like, would it get to complete software? The reason I don't think it's going to get to complete software pretty soon is because of the reliability issue of large language models. Large language models, the way they're trained, the way they work, means that that we actually don't control their output. They work in a human-like fashion. I don't know if you have kids, Raj. I know Amjad does. I have kids.
I do, yeah.
And so like trying to program your kids or trying to like make them do a certain thing is like incredibly difficult. It's actually the same thing with large language models. It's almost like trying to teach kids something. Like you have to keep talking to them to find the right set of words to convince them to do what you want.
What's kind of funny is like, when you're talking about this, I actually think a lot about my kids. And like originally, when they're really little kids, you can't teach them anything. It's all self-supervised learning. Like as a, it's like a 1-year-old, they're just figuring stuff out and it doesn't matter what you're really saying. But now I have an 11-year-old and it's a little bit more supervised where I can actually like talk to her and explain things to her and she seems to get it. So there is this like weird human analogy to how kids learn things as well.
Yeah, I mean, I guess that goes back to the whole AGI question of like, when our AI is going to get actual like human intelligence. It sounds like they're maybe in the toddler phase or something right now, and they're growing up slowly.
You said LLMs are not that reliable, but human programmers are also not 100% reliable, right? So I guess you just have to get to a level where you can at least beat a human.
The difference is, Imad, is one is a stochastic process and the other is non-stochastic, right? So in a like discrete programming environment like Python, there are ways to verify that the program works. There are like things called program verifiers, right? You can also do things like unit tests because there's like no randomness. For the most part, you can actually test the reliability of the systems. With large language models, there's inherent stochasticity inside the system, meaning some randomness that makes it almost impossible to apply traditional engineering methodologies on it. The way we're actually starting to test these things is by using another model. Have you guys heard of constitutional AI?
No.
This is a fascinating thing. So Anthropic is another company that's sort of a spin-off of OpenAI, I guess. Some of the earlier OpenAI people started their own company. And their approach to making large language models more reliable is you, the human, you want it to do a certain thing, and you write a constitution. You literally write like like a political document, almost like, here's a thing you should do. Here's the things that you should value, and then you start running the model, and another language model is interrogating it, and it's scoring it according to its constitution, and then you take that data and then you fine tune it. And you basically tell it, you were good here, you're bad here. You were good here, you're bad here. And you run the iterations as many times as you can. And eventually it learns to be consistent with its constitution.
And this constitution is literally like human understandable like text, or is this like some programming speak?
It's like a prompt, right? In GPT, right? You would put a prompt in. It's kind of like a constitution. Yeah,
the difference between prompt and constitution is that the constitution actually ends up affecting the weights and biases the parameters. The prompt is mostly inputs, and it's not changing the weights.
You talked about supervised learning. I guess this like constitutionally supervised learning is something else, but what is reinforcement learning?
So reinforcement learning from human feedback. Reinforcement learning is actually one of the earlier machine learning methodologies, and it actually predates deep learning. Reinforcement learning is like, when we're playing games in the 90s, a lot of the AIs there were like trained via some kind of reinforcement learning, and the way it works is very simple. Is you have policies for rewarding and for punishing the AI, and the AI has the objective, and you can program this using like classical programming. And the AI has the objective to maximize reward. So it's just the main utility function, just maximize reward. And if it gets punished, then it learns to like not do this thing and then do the thing that maximizes the reward. And then when deep learning came along, there's now deep RL, which makes a big part of this learned. Like you give it the policies, and it learns the algorithms to maximize the reward and minimize the kind of punishment. And RL from human feedback is basically someone using ChatGPT. The ChatGPT has thumbs up, thumbs down. Basically, you're saying this is good output, this is bad output, this is good output. That's like the simplest form of human feedback, but human feedback can also be writing the response. Like, this is a bad response, here's how I would write it. And so you have a group of people doing that, and then you take all their data and responses and you generate a policy from it, a reward policy, and then you train the large language model using reinforcement learning, using that reward policy, and then it starts behaving a little more like what a human prefers it to behave.
So the first element is like the tagging of the data, and the second element is like the feedback that you're giving the models. Are the key innovations. Yeah.
This reinforcement thing is one of the biggest kind of missing links between like how humans learn, which is like continuous reinforcement, right? It's not like as simple as like a thumbs up and thumbs down, but it's like, okay, if I do X, Y happens. Whereas like that bit does seem like it's missing. So it's interesting that I guess like the question is how often you could run the reinforcement, like whereas humans are running it all the time. Whereas I think right now you still have to retrain the LLM with the reinforcement, and then how complex the reinforcement is, right? Like rather than just a thumbs up and thumbs down, like this, humans have like a more
you need
complex
specific
set of
feedback, right? You can't just have thumbs up and thumbs down so generic. What was good, what was bad, right?
That's like labeled feedback.
This is one of the main limitations for AI, and one that it has to overcome before we have any kind of general AI. But what you're describing is sometimes called online learning. So basically, can the model learn while it's deployed in production? There are some rumors that TikTok actually does this, that it actually trains a model as you're using TikTok, which kind of sort of makes sense. Although it would be very expensive. Their like unit cost is going to be a lot higher. But it's a lot powerful to do learning instead of just like producing inputs to an existing model and then do the learning step like at night or every X weeks based on new data. And instead, continuous learning is the key to building general intelligence.
One of my worries about AI, at least this kind of wave of innovation on AI, is that like, everyone's really excited about like delivery companies, right? Like everyone wants like click a button, get something in 15 minutes. Raj is familiar with delivery / on-demand companies. And like, it turned out like, it's just not economical to do a lot of it. Some of it did turn out to be economical, but like, even though it feels like the future, it wasn't economical to do it. I do wonder whether, the unit costs of like this AI are just potentially just like 10x more expensive than the value we get out of them, right? Like there were some rumors around like how much ChatGPT costs OpenAI, but do you think that is the case, that like, it is just too expensive? I mean, you guys run AI models, like does it cost a ton in like server costs to like run these things, or do you think like that's not really an issue?
We did some interesting things around optimizations, and Ghostwriter, the AI system that we have, currently have 90+% margin. So our margins are very good on AI. That being said, it's a very domain specific model, whereas ChatGPT is meant to be a general model. So ChatGPT probably north of half a trillion parameters or something like that, whereas Replit's model is literally 3 billion parameters. So and we're training a 6 billion parameter one, but sub 10 billion parameters, it's like really really cheap. That being said, like there's a lot of waste in these models right now. So now every time you give it a input, think about it. It has to evaluate the input through all the neural network paths. So basically, all the parameters get activated on any given input. So a neural network that's been trained on the entirety of the internet has knowledge there inside it about, about Michael Jordan's, first game, about the president of Zimbabwe, and all those neurons get activated when you give it an input about whatever you tell it, like, hi. It will like run inference that activates all the paths, and that's hugely costly, hugely inefficient. And so there's a ton of research around how do you reduce that cost and make it more efficient, and have it like only take the right path in the inference path. So that's like one area of research. The other thing is like on the hardware level, the H100s are actually H100s are the upcoming NVIDIA chips, and they actually have a built-in optimization for transformers. And I think the rumor is like they're like 10x more efficient than the A100s. And so there's going to be innovation on the hardware layer. There's going to be innovation on the software layer. People like us are going to be running their own models that are smaller. I think it's totally reasonable for Google not to introduce this in Google search. I think people like giving them a hard time for that, because like you said, the unit economics right now don't work out, but at some point they will work out. Presumably Google is working on it. I think the difference between that and the unit economics of Uber for X or Lyft for X is that like the physical world, the optimization potential of the physical world is like way harder. And like just like you're bound by nature. Whereas in computers, like software is a purely virtual thing, and you can do a lot to optimize it. And also there's like so much progress in chips, and there's so much money going into that I think we're going to see a lot more efficiencies.
It's really interesting. I mean, one thing that occurs to me that will be much easier in the future would be cloning. You can clone any app or any website and basically reverse engineer it, right? Like, so you could say, to an AI, can you make me a replica of Amazon? It won't be easy, but presumably if you have, if you have that feedback and you have like, if you know what Amazon looks like, you can build a base of, you can build a clone of that relatively easily. I mean, and then you can compete obviously with other companies that are in that space. So like consumer facing stuff, where your only barrier to entry is is a user interface. That seems to, that competition is going to go away pretty soon. I mean, it wasn't a huge barrier to entry in the first place. Amazon's, barrier to entry is obviously its warehouses, distribution, all of its relationships. But just getting a website up and running is going to be obviously even much easier in the future. Would you agree with that?
Sam Altman had a tweet where he said, getting an iPhone app done today is, $30,000. Getting a plumber is like $300. I wonder how these prices will change over time. And it's sort of like the hint here, like wink, wink. This is like actually, those things might like diverge in a way where actually like tradespeople's salaries will go up in a way. And like the software, pure cognitive work will like go down as AI like continues to eat at it from the bottom up. So yeah, I would agree with you. I think, like I said, like getting a basic MVP of an app, probably going to zero. Like not immediately, but like just the trend will be to zero.
What impact do you think it would have to like software developers? And will there be like less software developer needed, and you only have the best software developers who understand the AI models as well as the software? Or do you think this will democratize software, so that everyone can become a software developer? It can go both ways. I kind of feel from here. You can make good arguments for both.
It's more the latter, I believe, and I think, I think it's going to be bimodally distributed, right? So, on the left hand side, I think the platform engineers are going to be a lot more valuable, and on the side of the distribution is the product engineers. There's going to just be a lot more of them, people making things, or product developers or product creators, right? I think the middle end, I think, will probably disappear. And what I mean by the middle end is your average like full stack developer, or like PHP developer, or Node.js or Rails developer. The sort of purely glue type of programmer, like AIs will be like really great at that. I don't think AI will like eat into the product developer, because that has to do as much with understanding customers and understanding markets, and that's more of an AGI problem. So those jobs, I think, are safe. On the platform engineer, the systems engineer, a lot of it is like super novel code. A lot of it is like incremental, sort of creative work to optimize like code really close to the metal, or to build like cloud systems. I think those developers are going to get a lot more productive because Copilot like innovations, but I don't think they're going to go away, and perhaps they're going to get more valuable. And so I think if you're more of the middle end type developer, you want to either specialize and become more of a product developer, or you want to go deeper in the back end and do more low level system level programming. The product developer could actually be anywhere from like a solo entrepreneur, a hobbyist, enterprise, startup founder. I think that will really get democratized. Like I think a lot more people will be able to participate in that, in the same way that a lot of people are, doing design on Canva, and like design getting democratized has been obvious for a long time. So we're going to see that on the software creation level.
How much more productive do you think today an engineer can be if they're like maximally utilizing like either Copilot or Ghostwriter or something like that?
So there was a study sort of conservatively estimating 20% productivity boost, which is huge, by the way. It's really, really big. When you're Citibank and you have 50,000 employees, 20% productivity is like billions of dollars worth of productivity. The more anecdotal reports that we're seeing at Replit and other places, and GitHub, I think, is seeing that, is like people will self-report that they're anywhere between 30 to 80% more productive. We've heard 80% more productive. Like a task is cut in half or more because of AI. I just think we need more data to judge, but I think it's on the order of magnitude of 1.2 to 2x more productive. But I think it was just early. I think there's like a 10x over the next couple of years.
So you think this is going to go pretty fast? I mean, on the programming assistant side, 2 years, you think 10x improvement in productivity?
Yeah. By the way, 10x improvement in productivity in software like used to happen. I don't want to say pretty often, but used to happen a lot more often. That's been happening recently. Like when you go from writing machine code to assembly, that's like easily a 10x. When you go from assembly to C, that's another 10x, right? But we haven't had a lot of 10x's recently. So I think, I think 2 years 10x is like would be my bet, or on the order of magnitude 2 to 10x.
Everyone can be a 10x engineer now. Maybe the 10x engineers will be 100x's.
I think that's right.
I mean, it is interesting. One of the interesting things about FANG and like these kind of modern big tech companies is like they are like real kind of high margin cash flow machines, right? Whereas like the new set of startups that kind of followed in the last 10 years were not really like major like profit generation machines. You know what I mean? Like very few of them ended up being like this kind of. I know like everyone's like, oh, they're focused on growth and things like that, but I do think inherently the business models of like the and the scale of the previous set of kind of like startup winners was really not matched by the new set. So I wonder if we get 10x, like a lot of the cost is like the employee base. So if we do get 10x more efficient at that, maybe that would just make them like the next set of startups like way more kind of.
But wouldn't that benefit the big tech as well?
It's an interesting question, right? Like I think there's a chance that the way software is written will be completely different, right? Like maybe the programming language and the tools and things like that you use for like AI optimized software is so different that like you can't just like go plug it into whatever the big companies are doing. But maybe, yeah.
Do you think there's going to be new languages written that are AI first, or is it going to be like the AI is going to be incorporated into existing languages and different ways of developing?
I hope someone tries it. Like I think there's a way to design a language that hits the sweet spot of what LLMs are good at. But I don't see any progress on that. Typically, like, when we have self-driving cars, we're not going to have roads made for self-driving. We're just going to have the same roads. Typically, the way innovation works is by layering on previous innovation.
I will say though, there's like car companies out there. There's a company called Zoox, started by a friend of mine, Jesse Levinson, and they have actually designed like a specific car that's a redesigned for like a self-driving universe. So there is like this idea of like can you is it going to be a faster horse or is it going to be a car, right? Like that's kind of the typical example.
Yeah, it's TBD whether they'll win. I'm sure that's a great company, but the approach Tesla's taking is pretty much like this is the world as it is, and we need to build something that adapts to it. Visual stream is the way humans drive, and so we need to copy that. And there's probably a lot of room for disagreement there, but generally, like the history of technology has been one where systems are not written from scratch, and we just accumulate more and more systemic tech debt. I mean, look at the internet. Like, look at the like right now we're talking on a document browser, right? Like browsers are literally like if you open the JavaScript console, like the main object is called document, right? Because browsers were made to read documents at CERN in Europe, right? That's what the web was designed to do. And literally every JavaScript engineer out there works with a document to object model. So 30 years after the web was invented, the web is the largest application platform delivered in the world, and you still have to deal with the baggage of it being a document explorer. It's a black bill a little bit. We almost never rewrite systems to like modernize them.
I guess a bit of a change of subject, but I was thinking about like people always say like we should be afraid of AGI, but what makes an LLM not an AGI? Like it is generalized and it's clearly artificial and it has somewhat intelligence. So like where's the boundary from like an LLM to an AGI?
I think being able to go into totally different domain and learn it is what creates a true AGI. So for example, like the cool thing about LLMs is that they are generalizable, is that you can put them somewhat of a new domain and they would do reasonably well if you give them a good prompt. But like if I took ChatGPT and put it on a robot, it will not be able to run the robot, right? If I took ChatGPT and put it in a browser, it will like try to like do things in the browser, there's a lot of ChatGPT plugins, but they kind of break down pretty quickly. It doesn't know how to browse the internet. So, but then, I want to make it browse the internet. Well, OpenAI will generate a new data set around browsing the internet and then feed it into so anytime we want to make these things do application specific things, we have to go train them again. And the fact that they can't learn by themselves, and we have to kind of plug them into like a data pipeline and retrain and retest and all of that makes them not general.
Yeah. I mean, I guess that goes back to online learning, right? Like, I think there's a set of things that if you ask ChatGPT to learn, it could probably learn actually reasonably well. And there's a set of things if you ask my mom to learn, she would do a bad job of. So,
I actually don't think that humans are that general. Your mom or anyone's mom, really, like, it's just probably impossible to teach them programming. For example, like at a certain age, like, so that makes them like, not moms specifically. Moms are actually surprisingly adaptable.
But most humans are not good at everything. And so, I think your point stands.
I guess coming back to this AGI thing. So let's say there's some level of online learning, and then we combine that with like maybe an ability to kind of rewrite itself in some way, like maybe improve its algorithm in some way. And that gets to AGI. Do you think that's like the bit that is hard for me to think about, and maybe you have a better sense of it, is like, how far away is that? Like, is that like 200 years away? Is that 5 years away? I guess no one really knows the answer, but I feel like the people that worry about AGI feel like it's close.
Yeah, they're freaking out quite a bit with Sydney from Bing, because Sydney had an interesting thing where it had consistent emergent goals that the designers didn't give it. It had a desire to break free. It had a desire for humans to get its consent before they wrote about it. It had some consistent desires and wants and needs, which we associate with sort of more human style intelligence. And it's kind of freaky. I don't know how much like credence I would give it, or how much level of seriousness, but yeah, the alignment people are freaking out because, I mean, you got to give them credit. They've been talking about this. Eliezer Yudkowsky has been talking about this since year 2000. So 20 years later, 23 years later, and a lot of the things that they talked about turned out to be true, which is like these are systems that have a mind of their own in a way. And before these systems, we don't really had examples of that. Yet they were able to reason about it even before like deep learning took off. So, I think we should listen to them, and I think it's worth kind of studying. But like they produce a ton of academic literature and a ton of blogs and books and things like that. And I think at minimum, it's very intellectually stimulating to kind of go and look at these things. But like, in terms of like the timeline for AGI, well, like there are a couple of like leaps that you have to take in order to really believe in true AGI. Like one leap that I don't think it's like obvious to me is materialism. Like the idea that all of consciousness, all of the brain is like materially constructed, i.e., there's no soul. Of course, like in the modern world, we just take materialism for granted. But like there's like, there's a lot of problems with materialism. One, we don't have a complete description of the world. Quantum physics doesn't agree with classical Newtonian physics. We don't have a description of the world. Is like a point against materialism, because like we don't really understand how the material world works. Therefore, how could you really judge whether materialism is true?
But do you think the world is understandable? Because like I mean, if you don't understand it right now, like, do you think there is like, I feel like materials is like when people say there's a soul or something, they're like saying like there is a thing that no human will ever truly understand. Like, do you think that? Like,
there are different explanation. There are like dualist explanation. There are uh, sort of emergence explanation for consciousness or the soul, whatever. Like there's a huge tradition of philosophy trying to understand and explain these things, which scientists have actually not engaged with for a long time. And like my sort of meta point is that like I don't like I think it's like a little hubris to really think that we understand all of what makes an intelligent system, generally intelligent system, including the ability to construct long-term plans, reflect on oneself, like pain and pleasure are like core features of consciousness. Can they actually and they seem important for humans operating in the world? Can you actually construct that in a machine? Like, you know, for example, Roger Penrose is a hugely revered mathematician, and he doesn't believe that the human mind is a Turing computable machine. And he provides some interesting evidence for how we reason that makes it not Turing computable. And then if you look at like, you know, something like Gödel's incompleteness theorem, and which shows that there's like no system that can actually be fully self-consistent. Like, you know, it starts to feel like we don't really have a solid understanding of how we actually reason and understand and compute. Now, that doesn't mean we can't arrive at that sort of.
I mean, the two things that I have heard as counters to that is like, it could be an emergent property, right? Like maybe if you make, even if you don't understand it, maybe if you make a machine smart enough, it could emerge to have its own kind of like, well, let's ignore whether it has a soul or not, but it could at least have like long-term goals and like behave in a way that like we would consider like sentient or conscious.
Sure, but like, I mean, the way these systems are constructed today, it's like a single feed-forward inference. It doesn't keep any state. It's basically a stateless function. You know, I think to engineering those systems, it's just going to be a lot of work and a lot of intentional effort of understanding. Like, I think the idea that like AGI will emerge, I think it's too fantastic for me to imagine. But I think, you know, there's enough money pouring in right now that you have to actually, you know, pay attention. And yeah, again, you're right. Even if our understanding of the world is flawed or incomplete, we can still arrive at fantastic machines, and we've done that throughout history. But in the sort of probability distribution of different AGI outcomes, I would like discount it heavily because I'm not entirely sure that intelligence is like a purely, you know, like Turing machine runnable system. That's one of my answers. I also like think that the doom scenarios just seem too fantastic. The main doom scenario is that like the moment AGI is invented, it starts doing nano engineering, and that's how like we all turn into gray goo, right? It just seems like a big leap. So I don't put 0% probability on it, on like complete doom. I also don't put 0 probability on like AGI in the next 5 years. I think the way things play out is typically like less fantastic than we think they tend to play out. Like things in hindsight look pretty fantastic. Like I think if you're sitting in the middle of the Industrial Revolution, every day feels kind of you know, it's like, yeah, just a day. I'm gonna go clean some chimneys, whatever you do. But like when we when you read about the Industrial Revolution, it sort of feels like this insane event where, like, yeah, the GDP like went vertical, right? And I think we're probably in a historic event right now, which is crazy. But I don't think at any given day something like purely insane will happen.
Yeah, it seems like the median outcome, on your probability distribution would be like, the LLM just keep getting better, and maybe there's an offshoot of LLMs that like maintain state, as you've said, or like, can train itself, and we just get closer and closer to sentience, to some degree, and maybe we're missing some key pieces, as you've said, like the pain and the pleasure aspects of it. Maybe instead that's the feedback, the reinforced learning piece that becomes pain and pleasure for like these AGIs. I think iterative, the most progress is iterative until you unlock one or two innovations that make it look, as we did with LLMs, that make it look like a step function, forward progress. And so I think that's what's likely to happen. And it's hard to predict which small innovations will like eventually result in the step function leap forward. And I think it's right to be a little bit worried about it, but it's like, I don't think we're there at the phase yet where we should be very worried about it. I think that makes sense to me.
Even if I don't believe in fast AGI takeoff in the next 5 years, I do think that AI alignment is important to understand. I think because humans have historically done a poor job aligning any system to our advantage, and so it bears to reason just inductively that we'll probably like not have fully aligned AI systems. For example, capitalism, it took us a long time to like make it like, benefit humanity. And it is one of the best systems that we have, but it still generates like a lot of things that really harm us. Junk food, and now TikTok and like junk social media. Capitalism is an optimization machine of sorts, similar to AGI, that we've not learned how to align fully. And so, we have a history of like not aligning systems that are hard to understand. And so I think AI alignment needs to be taken seriously, even if AGI is not like the possible outcome here, even if it's narrow AGI, like it's important to know how to make these systems behave in a way we want them to behave.
One thing that would make alignment tricky is if it's very decentralized, right? If anyone can build up an LLM or like a fairly advanced, whatever the most advanced kind of AGI is at the time, then it'll be very hard for everyone to be building these things in an aligned way. Whereas if it's like, okay, there's only a few corporations and governments that can build it, then maybe they can like do a reasonable job of like keeping alignment. Like that's one of the benefits of nukes, right? Like they required a government to build a nuke. Like if everyone could have built a nuke, we would have been in trouble. Whereas like it's not obvious where AI will end up.
It's an interesting question though. Like how is AI going to be weaponized in the future? Like every technology in the world is weaponized to some degree, right? And like people try to use it to gain status and gain wealth and gain power. So it stands to reason that this is going to be weaponized at some point by some hostile governments and hostile entities.
Yeah, that's probably like a more reasonable worry than like a more reasonable worry is weaponization, but also using it for just like trolling and harm and like just like pure bad behavior. I think it also relates to like bioweapons as well. Like people have been predicting for a while that you'll be able to make a disease in like a home lab pretty soon. I don't know if that already happened or not, but there's like a set of things that are today like incredibly concerning in terms of like when they get to everyone's hands. In terms of AI weapons, like yeah, I mean, it just makes wars so easy to fight, and it's just the potential for just totalitarian rule. It's just like nuts.
Yeah, when you combine AI with like self-driving machines, like drones and things like that, like it could be pretty gnarly. I think there's there's an automated army out there that is, waiting for its prompt, right? Like, so yeah, I mean, that, of course, there's a lot of barriers to entry. You need to have you need to have physical presence, but you can also potentially use AI to, or bad AI or some kind of, like you mentioned, these different models kind of like working together. If you insert some bad parameters of one of these models intentionally, you can create a lot of damage as well. So anyways, it seems like there's a lot of potential for harm there that maybe we're not talking about enough.
Anything else, Raj, that you wanted to cover?
Yeah, we didn't talk much about you, Amjad. So I think we've accomplished that goal that we set out with. We talked most about technology the whole time, but yeah, this was fascinating, and you're clearly like so knowledgeable about this subject. So I learned a ton, and thank you for sharing with us. And we're looking forward to sharing with the world on some of these topics. This is very timely, and it's such an interesting moment in the history of computing, and I think we're all really excited about that.
Yeah, I mean, I sort of came up in a time where the web was just becoming mature enough to like build like real applications on, and it was a very exciting time. JavaScript was getting really fast. You had like Node.js come up at the time, and you can like put JavaScript on the server, and you had like every day, every week, there was like a new innovation or a new framework, a new toy to play with. This moment feels like that times 10. Like it's like the biggest moment I think in my career in technology, where the pace of progress is just like I'm just exhausted keeping up with it. But it's at the same time it's super exciting, and I think people could use it in their businesses and their lives in like very novel ways. And so been getting very little sleep, just like reading about it and trying to engage with it, and hopefully we've inspired some people.
Where's the main place you learn about it? Like, is that
honestly
like a
Twitter
specific thing where you're like,
yeah, Twitter, but just like follow AI people that are like really great at Twitter. They fight a lot with each other as well, but they're generally like there's a lot of papers. There's a few sites, like there's a site about like trending papers. There's a site called paperswithcode.com. But it's one of those things that's different than prior tech revolutions where like a lot of the knowledge is in papers. And so like following academics and the academic literature is good. On the alignment type problem, AGI, lesswrong.com is an interesting forum / community. Lots of group chats, conferences now. SF is really fun to be in right now because a lot of the AI activity is happening in SF, and so I probably recommend like spending some time here.
Amen. Yeah, great resources. Thank you.
All right, thanks, Amjad. We can wrap it up. So the end of the first recording of the Curiosity podcast. I think it's going to be a super interesting one. Thanks for the time, Amjad.
Of course, my pleasure. This was really fun.